According to the National Transportation Safety Board, structural in-flight icing was identified as the cause or a factor in at least 52 aircraft accidents that resulted in 64 fatalities from 2001 to 2008. Icing is a potentially fatal in-flight, year-round hazard. Pilots should understand what it is, how it forms, and how to predict and detect it before it becomes an in-flight emergency. In a 3-part video series, we will discuss the different types of icing and how they form, what to do if you encounter icing conditions, the free flight planning tools available to pilots, and other resources to stay more weather aware. There are 3 types of icing: structural, engine, and instrument. Structural icing forms around the airfoil and its control surfaces. Aircrafts are affected by structural icing in several different ways, such as reducing thrust and lift caused by increasing weight and drag. These effects combine to increase the stall speed and reduce the overall aircraft performance. The 3 types of structural icing are clear, rimed, and mixed. Clear icing forms in the presence of visual moisture such as precipitation, fog, or a cloud, typically at temperatures from 0 degrees Celsius to -10 degrees Celsius. It forms from supercooled water droplets in clouds and in freezing rain beneath the temperature inversion layer. Clear icing is the most dangerous type because it's difficult to see when it's accumulating. It can accumulate rapidly, and it can form on areas of the aircraft that don't have ice protection systems. Rime icing typically forms in temperatures between -15 degrees Celsius and -20 degrees Celsius. This icing is commonly encountered in clouds and freezes instantly. Rime ice has a milky, opaque appearance resulting from air being trapped when it strikes the leading edge of an airfoil and freezes. Mixed icing is a combination of clear and riming ice that accumulates on the airfoil. It forms in the presence of moisture and temperatures between -10 degrees Celsius and -15 degrees Celsius. Note: pilots should be aware of an inversion layer, the warming of temperatures with climbing altitudes, especially if the temperature at the surface is at or below freezing. The inversion indicates potential freezing rain or freezing drizzle and sleet. Freezing drizzle and freezing rain are dependent on the drop size and distribution. They become dangerous because ice accumulates and degrades aircraft performance. Inversion layers can also form freezing fog, which can lead to a phase change from supercooled water droplets to ice. Next, we'll describe engine icing. Engine icing may form when air passes through either the carburetor venturi or fuel intake mixes with vaporized fuel and causes a significant temperature drop within the system. This icing restricts the flow of fuel and air to the engine. Although rare, engine icing and carburetor icing can occur at temperatures far above freezing and with no visual moisture. Induction icing can form at temperatures with -7 degrees Celsius to 21 degrees Celsius and relative humidities as low as 50%. A rough engine and cold carburetor temperatures indicate engine icing. Unfortunately, no weather products are available to predict engine icing. You can prepare for this type of icing by being aware of the temperatures and humidity during your flight, along with the signs that you are experiencing engine icing, like a rough running engine. Finally, we'll dissect instrument icing. Instrument icing accumulates along aircraft radio antennas or the pitot tube, where it distorts the ram air pressure for the airspeed indicator and can block the static port, rendering critical flight instruments unusable. It was found that pitot tube icing was the cause behind a fatal general aviation crash in Gaithersburg, Maryland, where the pilot lost their airspeed indicator readings and stalled on approach, resulting in a tragic accident. To summarize, there are 3 types of icing: structural, engine, and instrument. The most dangerous types of icing are those that sneak up on the pilot and can go easily undetected, like clear icing and induction icing. In the next video, we will go over some tools that we can use to forecast icing conditions.